Hey everyone, today we'll be going over the sorting algorithm insertion sort. It should take an array as input and return the array fully sorted as the output. We want to move down the array and compare each value to the value that comes before it. If the value before is less than our current value, then great, we don't need to move it. But if the value before is greater than our current value, that's out of order. So we'll need to switch the order of the two values. And we'll keep going until we reach a value that's already less than the value that comes after it. So let's write the for loop. Because the 0th index has nothing before it, we want to start with index 1. Now we want to store the value that we'll be comparing to all the values that come before it. Let's just call it temp. Next, we want to check all the values before temp until we reach the 0th index. And we only want to keep checking if temp is less than the value before, because it's not in order. If temp is larger than the value that comes before it, it's already in order, and we don't want to keep checking because that's inefficient. We're going to use j. We're going to start from the index before 1, so I minus 1. We're going to keep going until we hit 0. And we only want to keep checking if temp is less than the index before it. So like that. And we want to keep checking backwards. We want to start at our index and keep going until the 0th index. So we want to go backwards, not forwards. When we see that the number before temp is greater than it, then we want to switch their places so that the larger number comes after. So the value of index j plus 1 is now the value of j. What this does is that it keeps switching the larger number to the space after it until we reach the 0th index of j, or until the number at j is already less than our temp. And when that happens, the loop will end. So the value at index of j plus 1 is now equal to the value of the index of j. So let's say that we're at the second index, which is number 8. So 2 and 9 have already been sorted because 9 is less than 2. 8 is less than 9, so we put 9 at the second index where 8 used to be. But 2 is, so 9 is still in the first index as well. 2 is less than our current temp of 8, so we exit the for loop at j is equal to 0. But we still have the 9 at index 1 that we need to replace. So we need to insert our temp at j plus 1. So after the for loop ends, we're going to insert our temp at j plus 1 index. And we're going to return the array. So let's run it. And as you can see here, we have the array that's fully ordered. The best case time complexity of insertion sort is O of n if the array is already in the correct order. And the worst case time complexity is O of n squared.